We're picking up here with question 9. Question 9 says, how many different triangles can be made using a set of 6 points if no 3 of the points are collinear? In other words, we don't have any 3 points that are going to be in a straight line. And what that essentially means is I can connect any 3 points and I can make a triangle. Okay, and so we can pick different groups of 3 points and we can make different triangles. In the end here, the main idea is that, again, you've got these 6 points here, and any 3 that you pick would make a triangle. So really, we just want to do the combination of 6, choose 3, okay? I don't care about the order, right? If I pick point A, B, and C, that's the same triangle as picking C, A, and B, or B, A, and C, and so on. So it should just be the combination of 6, choose 3, and so you can stick that in your calculator, or you can use the combinations formula, and it ends up being 20 different triangles that you can create, all right? Moving into the probability questions now. Of course, we know probability is the number of successes out of the total number of possibilities. So really just counting problems like we were doing previously. Number 10, though, is a geometric probability problem. A circle is circumscribed about a square with 4 centimeter sides. If a point's chosen at random inside the circle, what's the probability that it is outside the square? Okay, so the circle is circumscribed about the square. So the circle is going to be on the outside. The square is going to be on the inside, using our geometry terminology here. We've got something that looks kind of like that. All right, so we want the probability that we pick a point inside the circle. So remember, probability of success out of total possible. So area of success out of total possible. So we want the area that, basically the probability that we get something in this shaded region, okay? And it says here that the square has 4 centimeter sides, okay? So that's 4, and that's 4, and so on. We need the radius of the circle to find the area, right? Area of a circle is pi r squared. And notice, this is a little 45, 45, 90 triangle here. So we've got sides of 4, 4, and if you know your 45, 45, 90 patterns, it's 4 radical 2. If you don't, you can use the Pythagorean theorem and you can simplify it. So that's our diameter of our circle. If the diameter is 4 radical 2, we can divide that by 2 to find out that the radius is 2 radical 2, okay? So the total possible area is the area of the circle. That's really what I'm trying to find right now. So we're going to take pi times that radius squared, and 2 radical 2 times 2 radical 2 is going to be 4 radical 4. Radical 4, of course, is 2. 4 times 2 is 8. So we end up getting 8 pi. And again, we know from, hopefully from previous courses, you don't want to round until the end of the problem. So basically our bottom of our fraction is going to be 8 pi. That's our total possible area, just a little bit more than 24. The top is the area of the shaded region. The shaded region is going to be the circle minus the square. So the circle area is 8 pi. The square area, it's a 4 by 4, which is going to be an area of 16. So it's going to be about 24-ish minus 16 would basically be the shaded region. And so that's going to be my success area. So 8 pi minus 16. Now, based on what we did this year, I'm okay if you leave it in that form. Really, thinking back to Algebra 1 and elementary school, you really want to simplify fractions, and so notice that 4 divides into all of these. So it would really be better 8 pi divided by 4, well, actually everything's divisible by 8 now that I'm looking at it. So 8 pi divided by 8 would just be pi, 16 divided by 8 would be 2, and 8 pi divided by 8 would be pi. So the best answer there would be pi minus 2 over pi. You know, if you wanted a decimal approximation, which the question does not ask you for, you could do pi minus 2 divided by pi, and that's about 0.363, so about 36.33%. if we were trying to do a percent. But anyway, question didn't tell me to round, so I would just leave it in that form. Again, on Our class this year, I'll take this answer, but really a better answer. You all have had Algebra 1. You should know how to simplify fractions. Okay, question 11. Fair six-sided die is rolled. What's the expected value? So, as I explained to you all in class, I had never seen expected value when I took my ACT, but basically you're saying, yeah, if you roll a die, what do you expect to get? And, you probably just say, well, I expect to get a middle-ish value, right? Either a 3 or a 4. And, common sense might tell you to average those two values, and you're going to get 3.5. So a lot of you probably could get the right answer without actually formally having seen the idea of expected value. But we have seen the idea of expected value. And so, a little more mathematical approach, really where expected value is coming from, is you're saying, well, okay, if I rolled this die a lot, what would I expect to happen? Well, for example, if I rolled it 6 times, I'd expect to get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Okay? But they didn't say what's the expected value for 6 rolls of a die. Let's see, what is that? 6, 10, is that 21? They didn't say what's the expected value for 6 rolls. They said what's the expected value for a roll. Okay? So if that's what I would get in 6 rolls, I think common sense would say you'd break that up by 6, right? Divide by 6, and you're going to get 3.5, which is that middle-ish value that I suggested before, okay? Of course, the more formal way to do this is to say, we're going to do this 6 times, we're going to divide the total by 6, and to recognize, oh, if I add all these up and divide by 6, that's really the same thing as taking 1/6 times 1, plus 1/6 times 2, plus 1/6 times 3, plus 1/6 times 4, plus 1/6 times 5, and I'm running out of space, plus 1/6 times 6. And we now have a little more sophisticated understanding of probabilities, so we can say, well, 1/6 of the time, I'm going to get a 1. Or 1/6 of the time, I'm going to get a 2. Or 1/6 of the time, I'm going to get a 3. And of course, OR problems, we're just adding all these things up. And if you work that out, you get the same thing. You get the same 3.5. So really 3 different ways you can think about that one because it's a pretty simple problem. In general, the formula for expected value is to take the probability of something happening times sometimes we talk about gain or loss. In this case, it's just the value of what you would get on each roll. So 1/6 of the time I get a 1, plus 1/6 of the time I get a 2, and so on. So pretty nice, simple formula to work with. Question number 12 is a continuation of expected value. Question number 12 says we have a home insurance policy for wind damage. It's $100 per year. Pays $1,000 if wind damage takes place. And a reminder, we already paid $100, so you're only actually getting $900 because you lost money paying into this. It says, what's the expected value for the consumer if there's a 5% chance of suffering wind damage in any given year? Well, based on what we saw before, you can take the probability and you can multiply it by the gain or loss each time. So it says there's a 5% chance of suffering wind damage. So we can take 0.05, it's 5%. And again, your gain would be $900, not $1,000, because you already paid $100 for the policy, okay? Or the other 95% of the time, you just lose the $100 that you paid in, okay? And you can do different things. You could say 5%, that's 1 year out of 20. And you could say, 19 years, I'm going to lose $100. And you could say 1 year, I'm going to gain 900. And then you could divide that by 20. That would also work. But the formula, I think, works pretty nicely for this one. Just remember, it's got to be the gain or loss. And you need to account for everything that can happen. So make sure that you've accounted for 100%. And in this case, it's -50, which would be -$50, really. And that just says that in the average year, you're going to lose $50. But, the peace of mind knowing that if something happens, you're going to be able to fix it without having to go into your savings, a lot of people are willing to pay for that.